Hello all, welcome to Docker Basics to Brilliance Course. My name is Kastro Kiran. In the last video, we have seen how to Dockerize a normal Java application. In this video, we are going to start a new concept that is available in Docker, which is known as Docker volumes. This particular concept I have divided into three parts, where in each part I'll be covering the theoretical concept of Docker volumes along with the practicals of the Docker volumes. As a part of this particular video, I will be talking about a brief overview on what is a Docker volume, how Docker volumes are going to help us, and the simple commands that are available in the Docker volumes. Along with that, I will also be showing you how to create a Docker volume by using one of the methods that is available as a part of Docker volume creation. Firstly, let us understand the typical definition of what is meant by Docker volume. Docker volume is actually a storage mechanism. Okay, it is actually a storage mechanism that allows the data to persist beyond the life cycle of a Docker container. This is the typical definition of what is meant by a Docker volume. So to speak about this particular definition, it is actually a storage mechanism. So Docker volumes are used to store the data. Okay, Docker volumes are used to store the data. So Docker volume is a storage mechanism that allows the data to persist beyond the life cycle of a Docker container. So here, what does it mean by beyond the life cycle of a Docker container? Suppose, let's say, usually in Docker containers, what will be there? Data will be available. Let's say the source code of the file or the application deployment will happen inside the Docker container. Now, when you delete a Docker container, what about the data that is available inside the container? The data that is available inside the container will also get deleted. Okay, whenever you store any application or whenever you deploy any application inside a container, let's say I have a Docker container. Inside the Docker container, I have deployed an application called Netflix application. Now, after some time, what I will do is I will delete this Docker container. Okay, I will delete this Docker container. So when I delete the Docker container, okay, when I delete the Docker container, what about this Netflix application? This application, whatever we have deployed inside the Docker container, that application will also get deleted. So that application will also get deleted. But we don't want it in this way. Let's say I will delete the Docker container, but I don't want the data inside the container to get deleted. I want to store this data, or I want to persist this data. So how will you persist the data that is available inside a Docker container? So if you want to store the data, okay, if you want to store the data that is available inside a Docker container, we are going to use a concept which is known as Docker volumes. If you remember, in AWS, we have the EC2 instances. We will be launching the EC2 instances. Now, let's say I have launched one EC2 instance. Inside the EC2 instance, let's say I have kept a simple index.html file. Index.html file. Now, when I access the public IP address of the instance, then what will happen? Whatever data that I have kept inside the index.html file, that data I will be able to see. Okay, that data I'll be able to see. But let's assume that I am going to terminate this instance. Now, when I terminate the instance, what will happen to this data which is available inside the instance? This file will also get deleted. Okay, this file will also get deleted. Now, even if I terminate the instance, I want the data inside the instance to be available. Okay, I want the data inside the instance to be available. In this case, in AWS, we have a concept which is known as EBS, Elastic Block Storage. So we can attach multiple volumes or EBS volumes to the EC2 instance. Now, inside these EBS volumes, I can keep whatever data I want. Now, when I keep the data inside the EBS volume, even when I terminate the EC2 instance, my data will still be available. That is something which is refers to the Docker volumes. So if you want to store the data, okay, if you want to store the data, instead of storing the data inside a container, that is Docker container, I am going to store the data inside a Docker volume. Okay, I'm going to store the data inside a Docker volume. Now, when I store the data inside a Docker volume, what is the advantage? The advantage is even if I terminate or even if I delete the Docker container, my data or the data that is available inside the container will still be available. How it will be available? Because I have stored the data inside the Docker volume, not inside the Docker container. So typically speaking, Docker volumes are meant for data storage. Okay, Docker volumes, I'll keep it as DV, which represents Docker volumes. Docker volumes are meant for data storage. So if you want to store the data, we will use a concept which is known as a Docker volumes. So a Docker volume is a storage mechanism that allows the data, okay, that allows data to persist beyond the life cycle of a Docker container. Even life cycle of a Docker container. Let's say the life cycle of Docker container has got terminated. That means the Docker container has got deleted. Life cycle has got ended. Even the Docker container has got ended up, or even if the Docker container has got deleted, my data will still be available. Data to persist beyond the life cycle of a Docker container. That is where we are going to use the concept of Docker volumes. So by using Docker volumes, what we can do? So Docker volumes are used to share the data. The Docker volumes are used to share the data between containers. Okay, Docker volumes are used to share the data between containers. If I want to share the data from one container to another container, then we can use Docker volumes. So Docker volumes are used to share data between containers, or it can also be used to retain the data. Okay, to retain the data when containers are stopped or restarted, or even removed. So when you stop the container, if you want to store the data, then we will use Docker volumes. If you want to share the data between different containers, or if you want to retain the data inside the container, when the containers are stopped, or when the containers are restarted, or when the containers are removed, then we can use the Docker volumes concept. We will be seeing a practical case scenarios how to share the data between the two different containers of Docker by using the concept of Docker volumes. We will be seeing that as a first demo of Docker volumes concept. But before that, let us understand the concept in detail. Now, in general, how many types of Docker volumes we have? So types of Docker volumes. So in general, we have three types of Docker volumes. The first one is known as named volumes. Okay, the first one is known as named volumes. And the second one is known as anonymous volumes. Named volumes, anonymous volumes, and the third one is known as bind mounts. Bind mounts. Named volumes, anonymous volumes, and bind mounts are the three different types of Docker volumes. Now, what is meant by a named volume? Okay, what is meant by a named volume? As the name itself tells, it is going to be named. The volume, when you give a naming convention to a volume, that's called as named volume. Okay, that's called as a named volume. So these named volumes are managed by Docker. Okay, these named volumes are managed by Docker. And apart from this, these are stored. Okay, these are stored in a default location. Okay, in a default location on the host. Okay, suppose let's say here what is meant by host? Host is nothing but the Linux operating system or the Windows operating system or the EC2 instance. That's basically the host. So where the data will be stored? The data will be stored by default on the host machine. That is an EC2 instance. So who will maintain these named volumes? Docker itself will maintain. We don't have to bother. Docker will maintain the named volumes. And these volumes are stored in a default location which are available on the host machine. That is basically the EC2 instances. And if you want, you can share the data. Okay, we can also share the data between the containers. Okay, we can also share the data between the containers. That's typically about the named volumes. Okay, named volumes are something When you give a specific naming convention to a volume or to a Docker volume, that's called as named volumes. And these named volumes are managed by Docker, and these named volumes are typically stored in a default location. Okay, this default location, where will be available this default location? It will be available on the EC2 instance. Okay, it will be available on the EC2 instance. And these named volumes, whatever data that is available inside these named volumes, we can share the data between different containers. Okay, we can share the data between different containers. That's about named volume. And then comes the next one, which is known as anonymous volumes. These anonymous volumes are something which are created by Docker when no name is provided. Okay, for these volume, anonymous means their identity is hidden. Okay, anonymous means their identity is hidden. That means when you don't give any kind of name or naming convention to the Docker volume, that's called as anonymous volume. So these anonymous volumes are created by Docker itself. Okay, we cannot create that. They will be created by the Docker itself. But what is the problem with these named volumes? The problem is they can be difficult to manage. Okay, they can be difficult to manage because they lack identification. Okay, they lack identification. So if you don't know which Docker volume if you want to go, then how will you go to that particular volume? So it's not possible. So that's why these are called as anonymous volumes. And the last one, which is known as bind mounts. Okay, the last one is known as bind mounts. Based on the concept of bind mounts, we are going to see a practical case scenario in this particular Docker volume series. Now, what is meant by bind mounts? Suppose here, if you want to link a directory, okay, if you want to link a directory or a file that is available on the host machine or a file that is available on a host machine. What is meant by host machine? An EC2 instance. So if you want to link a directory or a file on the host machine to a location inside the container, okay, to a location inside the container, then we will use a concept called bind mounts. Okay, if you want to link a directory or a file which is available on the host machine, the directory or file are available on the host machine. Now, these things you want to send it inside a container. Then in that case, we are going to do the bind mounts. Okay, then we are going to do the bind mounts, or we are going to use the type of volume which is known as bind mount volume. Now, how will you provide this? This concept will provide more control, but requires the host file path to be specified. We need to specifically mention about where exactly the file has to get copied and to which location it should get copied. That path we need to mention. So these are the three different types of Docker volumes. The first one is known as named volumes. Second one is anonymous volumes. And the third one is bind mounts. Okay, the third one is bind mounts. Now, by using Docker, okay, by using Docker volume, what exactly we are also going to do? Docker volumes are used to persist the data generated by Docker containers. Okay, Docker volumes are used to persist. Persist means to retain the data. Okay, to retain the data. That is called as persistence. So Docker volumes are used to persist the data, that is generated by the Docker container. Okay, that is generated by the Docker container. That's one of the advantages of working with the Docker volumes. Now, another advantage is using Docker volumes. Okay, using Docker volumes, we can decouple. Okay, we can decouple data storage from Docker containers. Okay, we can decouple data storage from Docker containers. Along with that, using Docker volumes, we can share the data among multiple containers. Okay, using Docker volumes, we can share the data among multiple containers. This also we are practically going to see as a part of Docker volume concept. We can share the data among multiple containers. From one container to another container, you can easily share the data. Okay, suppose let's say if you delete a Docker container, okay, if you delete a Docker container, will the Docker volume gets deleted? No. Why? Because the Docker volume is different and a Docker container is different. So when you delete a Docker container, Docker volume will not get deleted. That is why I was telling Docker volumes are used to persist the data. Persist means it will store the data. Even if you terminate or even if you delete the Docker container, the data will still be available inside the Docker volume. So that means if you delete the Docker container, that does not mean Docker volume will get deleted. Okay. So on deletion of Docker container, on deletion of Docker container, Docker volumes will not be deleted. Okay, will not be deleted or will not get deleted. Now, the other important point is we can create more than one volume in a single container. This is another point. We can create more than one volume inside a single container. Okay, inside a single container. That's another important feature of Docker volume. Single volume. Okay, one volume can be attached. Okay, one volume can be attached to multiple containers. Okay, one volume can be attached to multiple containers. But there is a logic here. But at a time, we can attach. Okay, at a time, we can attach only one volume to one container. So this is the concept that is related to the Docker volumes. Let me show you the simple Docker volume related commands so that you will get an idea about what exactly we are going to do with the Docker volume practicals. So Docker volume commands. I'll be giving just a plain level commands that are related to Docker volume. When we see the practicals, there we are going to see the high level commands also. The first command is known as Docker volume help. Docker volume --help. Now, when you will use this command, if you want to see the commands related to the Docker volume, okay, to see the commands related to the Docker volume, then we will use this command which is known as Docker volume --help. It will show you the list of commands. And then if you want to see the local volume, okay, if you want to see a local volume, we have a command which is known as Docker volume ls. Okay, Docker volume ls to see the local volume. Volume is nothing but Docker volume, to see the local Docker volume. By default, on the Docker engine, we will have a couple of volumes. Those are called as a default volumes. Okay, those are called as default volume. Suppose, let's say, if you want to create a volume, okay, if you want to create a volume, how will you do? Docker volume space the volume name. Whatever is the name of the volume that you want to give, you can give that name. By using this command, we can create the Docker volume. To create a Docker volume, we use this particular command, Docker volume space volume name. That's the next command. And then the next command is, suppose, let's say, I want to know the details of when the volume was created, at what time the volume was created, the metadata. If you want to know the metadata of a volume, okay, if you want to know the metadata of a volume, what is meant by metadata? To know the details. What is the name of the volume? What is volume ID? When it was created? At what time it was created? All those details are called as metadata. So if you want to know the metadata of a volume, Docker volume inspector space the volume name. Whatever volume you want to look for the data, that name you have to give. So to see the metadata, okay, to see the metadata of a volume, that is Docker volume. That's the next command. Suppose, let's say, I want to remove a Docker volume. Okay, I want to remove a Docker volume. If you want to remove the Docker volume, the command is Docker volume space rm space volume name. Whatever is the volume that you want to remove, that name you have to provide. So to remove or delete, to remove the Docker volume. Okay, to remove the Docker volume. If you want to remove all the unused volumes, let's say some volumes are there which you have created previously, but currently you are not using. So since the volumes are unused, you want to remove all the unused volumes. So if you want to remove all the unused volumes, Docker volume prune. Okay, Docker volume prune. So this command is used to remove all the unused volumes. To remove all the unused volume. Docker volume prune will remove or it will delete all the unused volumes. So these are the simple commands that you need to have an idea before we talk about the Docker volume practical case scenario. But before we jump into the practical case scenario, let me show you a brief overview about how Docker volumes are going to help us in the real-time scenarios. So let's understand how Docker volume is going to help us in the real-time scenarios. Practically, we will see that. Let's say I have a file, a netflix.java file is available. So inside this file, that is .java file, I have the code that is related to the Netflix application. Now, what I will do, usually this application, we are going to deploy into the Docker containers. Let's say I have the Docker engine. Okay, I have the Docker engine. I have installed the Docker inside the EC2 instance. Now, inside the Docker engine, what we usually do, we will create the Docker containers. Okay, we will create the Docker containers. Let's say I have container 1 inside the Docker engine. Now, inside the container 1, let's say I have a web server. Okay, I have a web server. That web server, usually it can be Nginx, it can be Tomcat. Currently, I'm taking the web server that is available inside the container 1 is Tomcat web server. Okay, Tomcat web server. So initially, I have the application code. Let's say the file is available. Inside the Docker engine, I have the Docker container. This is the first container. Inside the Docker container, I have the web server, which is known as Tomcat web server. Okay, which is known as Tomcat web server. Now, this container, okay, this container, where it is running inside the Docker. Okay, this container is running inside the Docker. The web server, that is Tomcat web server, where it is available inside the container 1. Container is there inside the Docker engine. Tomcat web server is there inside the container. Okay, inside the container. Now, this container, okay, this container, that is whatever the Tomcat web server that is available inside the container wants to access a file which is netflix.java file. By using this container, I want to access this file called netflix.java file. Yes, it is possible. We can access it. But at the same time, let's say I have one more container in the same Docker engine. Now, inside this container 2, I have the web server, which is known as a Tomcat web server. Now, this container also wants to access the same Java file. Container 1 and container 2, both the containers wants to access the same file that is available. Okay, the same file that is available. Now, what will happen is I will do some code changes in the netflix.java file. Okay, I will do some code changes in the netflix.java file. So whenever I do the changes in the netflix.java file, those changes should be available both for container 1 and also container 2. Okay, both for container 1 and container 2. So here what I am doing, the same file I am sharing between two containers. So is it possible that sharing of data between two containers, same data I am sharing for two different containers. So when I change the data here, okay, when I change the data here, the application that is running in the container 1 and the application that is running in the container 2, both they will have the updated version of the application. Okay, that is how you can share the data between the different containers. Same data, you can share the data between different containers. That is when we are going to use a concept which is known as Docker volume. Directly, we cannot share the data. So if you want to share the data from one container to another container, then we have to use the concept of Docker volumes. Okay, if you want to share the data from one container to another container, then we have to use the concept called Docker volumes. That's about the Docker volumes in a practical case scenario. Let us understand one more scenario. One more scenario is, let's say I have a container. Okay, let's assume that I have a container. The name of the container is container 1. Now, inside the container, what I have done is I have created a volume. Okay, I have created a volume. And the name of the volume is volume 1. So here I have one container. The name of the container is container 1. And inside the container, I have created a volume. The name of the volume is volume 1. Let's say that inside this volume, Okay, inside this volume, I have some files. Let's say some three files are available. Inside the volume one, I have some three files. Now, this volume one, okay, this volume one, can we share it to another container? That's the question. Can we share the volume to another container? Yes, it is possible to share the data that is available inside a volume. That is what we have learned from the Docker volume basics. Now let's assume that I have the second container. Okay, I have the second container. Container 2 is there. Now what I want to do, can I share the volume 1, which is available in container 1? Yes, we can share. Let's say I have shared the volume 1. Now inside the volume 1, which is available in the container 1, three files are there. Now, when I share this volume, the data inside the volume also will get shared. Yes, the data inside the volume will also get shared. So here what is happening? The same volume is being shared between two different containers. In container 1, volume 1 is there. In container 2 also, volume 1 is there. Suppose, let's say, in the container 2, I have the volume 1. Now, in container 2, where volume 1 is there, can I create additional files? Yes, we can create additional files. Let's say I have created the additional file. Now, where this additional file is available? It is available in the container 2, volume 1. Now, this file, whatever you have created inside the container 2, will it be available in the container 1 volume? Yes, it will be available inside the container 1 volume. So here what we need to understand is, if we create any extra files, okay, if we create any extra files inside the container 2, those files will automatically gets replicated into the container 1. What is the reason for this? I am creating the files in the container 2, but they are also getting replicated inside the container 1 as well. What is the reason? The reason is very simple. The reason is both containers have the same volume. Okay, both containers are having same volume. If the volumes are different, then there is no problem. The data inside each volume will be different. Since volume 1 is being shared between container 1 and container 2, whatever data that you keep in the container 2 of volume 1, the same data will get shared into the container 1 volume 1. Suppose in container 1 volume 1, if I create some extra files, will they get replicated in the container 2 volume 1? Yes, they will get replicated. Why? Because I am sharing the volume here. Okay, this is because the volume is same and it is shared between both the containers. What is the reason for this? This is because the volume is same for both the containers and it is also shared. Okay, it is also shared. The same volume is being shared between both the containers, and that is why whatever files you create in the container 1, the same files will get replicated inside the container 2 as well. When they get replicated, when both container 1 and container 2 share the same volumes. If the volumes are different, then the data will not get replicated. Only when the volumes are same, then only the data will get replicated. This concept is known as decoupling. Okay, this concept is known as decoupling. So we can say that volumes are loosely attached. Okay, volumes are loosely attached. What does it mean by loosely attached? They are decoupled, they are separated. Okay, they are decoupled or they are separated. So let's say when you delete the container, will the volume get deleted? Let's say I have deleted this container 1. What about the volume 1? Volume 1 will get deleted? No, that is what we have understood. So if you delete the container, the volume will not get deleted. Though the volume is there inside the container 1, the volume will not get deleted. Okay, the volume will not get deleted. Only the container will get deleted. So this is all about the concept of Docker volumes. I hope you got an idea about what is meant by Docker volume, how Docker volumes are going to help us in order to store the data and share the data between the different containers. Now, in order to create the Docker volumes, there are different methods that are available. So by using Docker file, we can create the Docker volumes. By using CLI, we can create the Docker volumes. And by using a couple of other methods also, we can create the Docker volumes. In the next video, we will understand how to create the Docker volumes by using two different methods. That is, one by using Docker file and the other one is by using CLI. I'll be showing you 4 different ways of how to create a Docker volume in the next video and also in the next to next video. Thank you.